Section 2.2.26. The data to the right represent the number of customers waiting for a table at 6 p.m. for 40 consecutive Saturdays at Bobak's restaurant. Complete parts A through H below. So, are these data discrete or continuous? And then we're going to explain. Well, let's go back through the definition. So a discrete variable is a quantitative variable that has either a finite number of possible values or a countable number of possible values. A continuous variable is a quantitative variable that has an infinite number of possible values that are not countable. The data is countable because it is possible to count the number of customers waiting for a table. So if it is countable, then we're going to say that it's what? It is a discrete variable. Part B, it says construct a frequency distribution of the data. So since we're given the classes, we want to find everything from 1 to 3. So we have 1, 2, and 3. So we have 3 for the frequency for the first one. Then we have 4 to 6. So we have 1. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then we have 7 to 9. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16. Then we have 10 to 12, which is, see here. So we have 1, 2, 3, 4, and then 5. And then what's remaining is 13 through 15, which is 1, 2, 3. So there's our frequency distribution. Now we're going to construct a frequency distribution of the data. So we need to find the sum of the frequencies. When we add up the frequencies, 3 plus 13 plus 16 plus 5 plus 3, it's going to give us a total of 40. And then we're going to construct a relative frequency distribution. So the frequency for the first class is 3 over 40, which gives us 0.075. The second class, 13 divided by 40 gives us 0.325. The next, 16 divided by 40 gives us 0.4. 5 divided by 40 is 0.125, and 3 divided by 40 is 0.075. Okay, and then the relative frequency distribution found in Part C, it shows the relative frequency of each category. We want to find out what percentage of the Saturdays had 7 or more customers waiting for a table at 6 p.m. So 7 or more, we got 7, which is at 0.4. 10 or 12 is still more than 7. And this is also more than 7. So we're going to add up all of these numbers. So we have 0.4 plus 0.125 plus 0.075, which gives us 0.6. But we want to write this number as a percent. So we need to take this number and multiply it by 100%, which means we need to move a decimal over twice. So we get 60%. So what it's saying is that 60% of Saturdays that had 7 or more customers waiting for a table at 6 p.m. Now we're going to find what percentage of the Saturdays had 6 or fewer customers waiting for a table. So here we have 6.325, and then classes 1 through 3 is 0.075. So we're going to add those together to get 0.4. And then we're going to write this number as a percent by taking 100%, multiplying it 0.04 to give us 40%. And therefore, 40% of Saturdays had 6 or fewer customers waiting for a table at 6 p.m. Okay, so the next question wants us to construct a frequency histogram of the data. So we're going to go ahead and do that using StatCrunch. So we're going to pull up that question. And the data is located right here. So next to the data, you're going to see the icon for click to copy the table. We're going to open up in StatCrunch, and we're going to construct a frequency histogram. Now sometimes you may have an oops on a page. You might have to reopen it again so that it pops up. Okay, so we're going to go ahead and graph this. So we're going to go ahead, graph, select histogram. We're going to select our column. And so what do we know about the starting point? Well, it's starting at 1. We know our class width is 4 minus 1, which is 3. So we can put that into our width. And then the next thing we want to do is, if we want to label the x-axis, we can, just so that we can see what that looks like. And so labeling the x-axis, we have number of customers. And then we're going to select compute. So let's go ahead and copy that. Okay, so there is our frequency histogram. Okay, then now we're going to graph and construct a relative frequency histogram. So using the same data, we're going to select graph, go back to histogram, select our column, and then we're going to choose from the drop-down menu the relative frequency. Make sure our width, our starting point is at 1. Again, our width is going to be 3, our class width. And then we're going to label our x-axis as the number of customers. And then we're going to select compute. And then from here, we're going to compare to our result. And so we can see here that we've created a relative frequency distribution. Okay, now we're going to describe the shape of the distribution. And so recall that a distribution is symmetric if the right and left sides are approximately mirror images, if the histogram is split down the middle. A distribution is skewed right if the tail to the right of the peak is longer than the tail to the left of the peak. And a distribution is skewed left, the tail to the left of the peak is longer than the tail to the right of the peak. So if you take a look at this graph here, okay, the distribution is skewed right because the right tail is longer than the left tail.